Hi everyone. In this video, we would be designing Amazon locker system, which is one of the most popular question asked in Amazon interview round. So let's get started. Now let's try to understand the system. So this is how the Amazon locker would look like. Each and every locker in the world would have their unique name associated with it. All right. So this is the name for this particular locker. This locker would have one display screen. It would also have one keypad with which you can enter your OTP, and it would also have one scanner so that delivery agent can scan the barcode on the package. All right. And this locker would have many slots, as you can see over here. Some of the slot would be small and some would be very large. All right. So now I hope you understood how the Amazon locker would look like. So in this video, we'll try to design three different flows. The first one is the locker selection flow, wherein the customer would be selecting one nearby locker as the delivery address. The second one is the delivery flow, wherein the delivery agent will come to this locker and deliver the package. And the third one is the pickup flow, wherein the customer would go to this locker and collect the package. All right. So these are the three different flows which we would be designing. But before that, let's try to understand these three flows. Now let's try to understand the first flow. So for that, let's assume that you are currently on the checkout page. So obviously on the checkout page, you need to enter your delivery address, right? So instead of entering your delivery address, you can also choose the Amazon locker as your delivery address. All right. So in order to choose the Amazon locker, you need to first search the locker based on these parameters. So let's say you want to search the locker based on the zip code. So you'll select this option and you'll enter the zip code over here. And then you'll click on this search button. Once you click on this search button, all the eligible lockers would be shown to you. Okay. I'm highlighting this word eligible. Why? Because let's say there is one locker which is completely filled, or let's assume that there is one locker which is not filled, but your package cannot fit into that locker. So obviously showing that locker onto the screen is not good, right? So only eligible lockers would be shown to you. All right. So let's say these are the three eligible lockers in this particular zip code. All right. Now what you'll do is you'll select one of this locker by clicking this button. Once you click this button, this locker would be added as the delivery address for your order. All right. So once you place your order, two things would happen. The first one is the slot of the chosen locker would be reserved. And the second one is the delivery agent will be assigned for the delivery of the package. So these are the two things which would happen when you place your order. All right. So I hope now you understood the first flow, which is the selection of the locker. Now let's try to see the delivery and the pickup flow. So in the delivery flow, the agent would first come to this locker. He will touch the screen. Okay. Here it clearly says that you have to touch the screen. Okay. Then once he touches the screen would look something like this. So over here, the delivery agent has to click on this option, which says the carrier entry. Once he clicks on this option, he would have three different options. The first one is the collection. So this is generally used when the customer is returning the product. So once customer returns the product, the delivery agent has to collect that product, right? So in that case, this option would be used. But currently we are not implementing that flow. So the delivery agent would be selecting the second flow, wherein he is telling this Amazon locker that he has come here for delivering the package. All right. So the Amazon locker would then ask the delivery agent to scan the barcode of the package. All right. So the delivery agent will be scanning the barcode through the scanner. Once he scans the barcode, the slot which was assigned to that package would open. All right. So let's say this was the slot. So the door of this slot will open. So he'll place the package into this particular slot and close the door. Once he closes the door, two things would happen. The first one is OTP would be generated. And the second thing is that the customer would be notified that you have to go to this locker and enter this OTP within, let's say, 3 days. So this was the second flow, which is the delivery flow. Now for the customer flow, the customer would obviously go to this locker, touch the screen. then the screen would be prompting the customer to enter the OTP via this particular keyboard. So customer has three different choices. First one is to enter the OTP with this keyboard. Second one is to enter the OTP with this physical keyboard. And the third one is that the customer can scan the QR code. So in the email, along with the OTP, the customer would also receive the QR code. So either customer can use the QR code or customer can enter the OTP. So whatever customer wants to do, he will do, and that OTP will be validated. If it is valid, then the door of the appropriate slot will be opened. And finally, the customer will be collecting that package. So I hope now you understood all the three different flows. Coming to requirements. The requirements are quite simple to understand. So basically you have to design these three flows, and while designing these three flows you have to keep two things in mind. The first one is your system should be extensible, and the second one is the first flow should be thread safe. Okay, we'll directly understand this thing with the help of class diagram. So let's check out the class diagram. Now let's check out the class diagram of Amazon locker system. So first let's begin with the locker selection flow. So the locker selection flow will start with the locker service itself. So this is the locker service. So if you remember, the first thing which the customer will do is search the locker by the zip code, right? So once they enter the zip code and click on the search button, this function would be called. This function basically fetches all the lockers which are present in the zip code. Okay. So it will interact with the repository layer in order to get all the lockers which are present in this zip code. Okay. So all the lockers are stored into this hash map, wherein the key of this hash map is locker name, because each and every locker would be having their unique name, and the value would be the locker object, right? So first we would be fetching all the lockers by the zip code, and since we have to only show those lockers which are eligible, that is which has at least one slot where this package can fit, right? So for that we'll be iterating through all the lockers which are present in that zip code and check whether it has at least one slot where this package can fit. Okay. And when the customer places the order, at that time the second function, which is reserve slot for package, will be called in order to reserve one slot of the chosen locker for this package. So in this function, we would be first getting all the eligible slots of this chosen locker. So we would do that with the help of this function, which will basically get all the eligible slots in that locker. And let's say there are 5 eligible slots. So in that case, we have to select one, right? So for that, I am using this slot assignment strategy, wherein I'll be passing all the eligible slots in the chosen locker, and I would select one of them based on this strategy. So currently I'm using this first fit slot strategy. Similarly, you can introduce more strategies if you want. Okay, so here we'll be using the strategy design pattern, wherein you can modify the algorithm of this assigned slot function. Okay. So I hope now you got the two main functions which will be present into the locker service, right? So basically this locker service will interact with the locker repository. This locker repository will interact with the hash map. And there is one more hash map, which is zip to lockers map. Now what is this? So for that, let's first try to understand this locker. So this locker would be having one unique name. It will also have the status. So locker will be either in idle state or customer pickup state or carrier entry state or agent delivery state, right? So these were the 4 photos which we saw in the beginning, isn't it? And locker will be present in one specific zip code. So it will also have the zip code. And one locker will have many slots. So that's why I have this hash map, wherein the key is the slot ID and the value is the object. Okay. So since I want to fetch all the lockers based on the zip code, I am also having this map, wherein the key would be the zip code and the value would be the list of lockers which are present in that zip code. Okay, so that this function becomes more efficient because of this hash map. Otherwise, we need to iterate through all the lockers which are present in the world, isn't it? So I hope now you got the locker repository and locker. Now this locker will have many slots, right? So that's the reason why we have one has a relationship between the locker and the slot. So each and every slot would be having the slot ID, the size of the slot. So size would be having these dimensions like length, width, and height. And it also has this can fit function, which will check whether this package can fit into this slot or not. If it can fit, then obviously it would return true, as it would return false. Apart from size, it also has this available atomic boolean variable, because we need to update this availability of the slot atomically, right? We don't want two users to have the same slot, isn't it? So that's the reason why I am using this atomic boolean variable. And each slot can have one package, right? It would be either null or it would be equals to some package object. So slot will have one has a relationship with the package. Now the package would have the package ID, which is used for the barcode scanning purpose. And this package belongs to some customer, isn't it? So that's the reason why we have this customer ID. And this package will be delivered by some agent. So that's the reason why we have this agent ID. And this package would be delivered to some address. So over here we have the locker name and the slot ID. Okay. And package would be having its own size, which is basically the combination of this length, width, and height. And package would also have the status, that is whether it is created or assigned to agent or out for delivery, etc. All right. So I hope now you understood the entire locker selection flow. And one more thing that I forgot to mention is, once you place the order, apart from reserving the slot, you need to also assign the agent. Okay. So this second step will be done with the help of this agent service. So in the agent service, we have a function called as assign agent for delivery, which will be basically assigning the agent. So in order to understand this function, let's first try to understand delivery agent class. So each and every agent would be having the ID and the name, and it would also have the serviceable zip codes. So see, one agent will obviously not be delivering the package to the entire world, right? He will not deliver the package to all the lockers in the world, isn't it? He will only deliver the package to some lockers or some zip codes, right? So that's the thing. I need to first get all the agents which can deliver the package to a specific zip code. So zip code would be present in this locker. All right. So I need to find all the agents which can deliver the package in that zip code. So I'll be doing that with the help of this hash map, wherein the key is the zip code and the value is list of delivery agents. Okay. So I'll call this get by zip function. So now let's say there are 5 delivery agents which can deliver the package to this locker. Now I need to select one of them. So I'll do that with the help of this strategy design pattern. Okay. So currently I'm just using this random agent assignment strategy, which will just pick one of the eligible agent. Okay. But in future, you can add different strategies for agent assignment process. All right. So now I hope you understood how the agent is assigned and when the agent is assigned. And yeah, one more thing is, once the agent is assigned, you need to notify that agent, isn't it? So at the end of this function, you will be interacting with the notification service in order to notify the agent that this is the package which you need to deliver at this locker. Now let's see the code for the locker selection flow. So in the locker selection flow, the first thing is the customer will be entering the zip code, right? Once the customer enters the zip code, all the eligible lockers are shown onto the screen. So the customer will select one of those eligible locker and place the order. So when the customer places the order, the first thing that happens is one of the slot of this chosen locker is reserved. And the second thing is the delivery agent is assigned for the delivery. Now let's see the implementation as well. So first let's go to this get eligible lockers by zip code and the size. So for that, we would be interacting with the locker service. So in the locker service, since we need to get all the lockers by the zip code, we need to first interact with the locker repository. So in the locker repository, we have this function called as get lockers by zip, which will basically return all the lockers based on the zip code with the help of this hash map. All right. Once I get all the lockers present in the entered zip code, I will iterate through all of those lockers and I will check whether those lockers has at least one slot which can fit this package. If there is at least one slot available in the specific locker, in that case, I'm adding that locker into this resultant list. All right. So this function will basically give me list of eligible lockers. Once I get all the eligible lockers, I will be selecting one of the lockers, right? And once the customer selects the locker, he will place the order. So when the customer places the order, this function of the locker service will be called. So in this function, we would first get all the eligible slots for the chosen locker. All right. So let's see this function. So for that, we would iterate through all the slots of this chosen locker and we would check whether that slot is available or not and whether it can fit this package or not. If both of this condition is true, in that case, I will be adding that slot into this resultant list. Okay. So this is how we would be getting the list of eligible slots. Once I get list of eligible slots, I would be passing that slots to this slot assignment strategy, which would help me to pick one of the eligible slot. So let's see this function. So currently we would be using this first fit slot strategy, which would basically go through all the eligible slots from left to right and check whether it is available or not. If it is available, then reserve that slot. Okay. So this function is atomic. Why? Because we are using this compare and set function of this atomic Boolean variable, which will basically convert this available from true to false atomically. All right. So even if two threads try to call this function simultaneously, only one of them would be successful in converting this available variable from true to false. Okay. So the thread which wins or which is successful in acquiring that slot will return this slot. The thread which loses will be going to other slot in this eligible slots. Okay. So we would be reserving the slot, and once I reserve the slot, I will update some of the package details, and finally I would print some stuff. Okay. Now once the slot is reserved, the second thing which would happen is the agent would be assigned for the delivery. So let's see this function as well. So in this function, in order to assign the agent for delivering the package to this locker, I need to first get all the agents who can service in that zip code, right? So first I will be getting the zip code which will be present in this locker, and then I would be interacting with the agent repository with the help of this get by zip function. Okay. So this function will basically return me all the agents which can service in this particular zip code with the help of this hash map. All right. So once I get all the agent who can service in that zip code, I will be assigning or I will be picking up one agent for the delivery with the help of this strategy. So currently I am using this random agent assignment strategy, wherein I'll be selecting one of this random agent. Okay. So one of the random agent will get this order, and that agent would be delivering this order or delivering this package, right? So once I get this agent, I am just updating some of the package details, like this is the delivery agent who would be delivering the package, and the status has been updated to assigned to agent status. All right. And finally, I will be notifying the agent stating that this is the package which you have to deliver to this particular locker. All right. So I hope now you got the entire locker selection process, which consists of two steps. The first one is searching the locker based on the zip code. Second one is the placing the order, which would consist of reserving the slot and assigning a delivery agent using the agent strategy. Now let's try to understand the agent delivery and the customer pickup flows. So for that, let's try to understand this locker machine. Why? Because this is the physical machine which would be used by both the agent as well as the customer in order to deliver and collect the package. So this machine has various services because it would be interacting with those services at various steps like locker service, package repository, OTP service, notification service, etc. And the main thing this locker machine has is the state. Okay. Why? Because this locker machine would be in different states. Like it would be in idle state, customer pickup state, agent delivery state, etc. Now, why am I using the states? Or why am I using the state design pattern over here? Let's try to understand that. So I saw one YouTube short where one lady was trying to enter the OTP for the package. Okay. But even though the OTP was correct, nothing was happening. No slot was getting opened. Why? Because at that time the locker machine was in the idle state. So she tried to enter the OTP couple of times and later she realized that the locker is in the idle state. That is, the locker was asking the customer to touch the display screen first. Okay, so she did so, and after that the locker machine went from idle state to the customer pickup state. So in the customer pickup state, she again tried to enter the OTP, and that time the OTP was validated and one slot got opened. Right? Now the reason behind that is this validate code function, which is nothing but the enter OTP function. Okay. This function earlier in the idle state was empty. Okay. It was empty, but the same function in the customer pickup state has the actual logic. All right. So the point to observe over here is the functions which are present in the locker machine have different behavior based on the state of the machine. Okay. Earlier, this validate code function was empty, but now the validate code function has some implementation into it. Okay. So that's the reason why we are using the state design pattern, wherein the functions would behave differently based on the state of the machine. Okay. And further, this validate code function will behave differently compared to the validate code function in the agent delivery state. Why? Because in this customer pickup state, this code would act as the OTP code, wherein in the agent delivery state, this code would act as the package ID. So when the agent scans the barcode on the package, the same validate code function would be called, but now this code would act as the package ID. All right. We'll directly try to understand that in the code if you haven't understood. But I hope you understood that why we are using state design pattern over here. Okay. And in all of the states, I've highlighted some functions with red color. Why? Because those functions would be having some implementation into that state. That is, in the idle state, this touch function would do something. It would have some logic, whereas all the other functions would be empty. All right. Similarly, in the customer pickup state, validate code function and close door function would have some logic. Also, there would be one function called as select carrier entry. So these three functions would have some behavior. Other function would be empty in this customer pickup state. All right. And one more thing that I want to highlight is when the agent would place the package into the appropriate slot and close the door, at that time, two things would happen. The first thing is this locker machine would interact with the OTP service. All right. And it would call this generate OTP function. So this generate OTP function will use this OTP generation strategy. So currently I'm using the numeric OTP generation strategy, which would generate one numeric OTP. Okay. And it would save that OTP in this hash map with the help of this repository layer. All right. So this is the first thing which this locker machine would do. And the second thing would be it would notify the customer with the help of this notify customer function. It would notify the customer that this is the package which you need to pick up from XYZ locker, and this is the OTP which would expire in 3 days. All right. So this OTP info would store total 4 stuff. The first one is the OTP. Second is the expiry time. Then it would also store the locker name. Why? Because see, you cannot go to any other locker and type the correct OTP. It would not work. You have to go to the correct locker and enter the correct OTP. So that's the reason why we have this locker name as well. And we also have this slot ID, because when you enter the correct OTP, one slot should get opened, right? So for that, I will be having the slot ID. So in the OTP service, I have one function which is validate the OTP and get the slot ID. So this function will check whether the OTP entered by the customer is valid or not. And if it is valid, then it will return me the slot ID. So this locker machine will get the slot ID, and with the help of some physical device, it would open the appropriate slot. Okay. And this OTP service has one more function, which is invalidate OTP. So once you enter the correct OTP, that OTP will be removed from this hash map. Okay. Why? Because we don't want the user to enter the same OTP again and again. We'll just remove that OTP. So in that case, the customer needs to be very careful. Why? Because if the door gets closed before that customer picks up the package, then there is no way to open that door again. Okay. So I hope now you understood the agent delivery flow and the customer pickup flow, right? Now let's try to understand the code for the agent delivery and the customer pickup flow. So first of all, we have this physical locker machine, and the agent and the customer both will go to this physical locker machine in order to either deliver the package or collect the package, right? So first of all, the agent will go to deliver the package. So the status of the package at that time would be out of delivery. All right. And then once the agent reaches the machine, he will first touch the screen. Then he will select the carrier entry. Then he will select the drop package option. And then he will scan the barcode on the package. So once he scans the barcode, this function would be called. All right. And after that, he will place the package into one of the slot which got opened, and then he will close the door. Once he closes the door, the OTP would be generated, and that OTP would be sent to the customer. All right. Then the customer will go to the machine. He will touch the screen. All right. Then he will write down the correct OTP. Okay. And after that, he will close the door after collecting the package. Okay. So I hope now you got the flow for the customer pickup and the agent delivery, right? So now let's see the implementation of this as well. So first of all, we have this locker machine. This locker machine will have various services so that it can interact with those services, and it will have this locker state. Okay. Locker state will have these functions, and each and every state would have different behaviors for these functions. All right. Those functions are also present in the locker machine as well. So in the machine, this function would only take certain parameters. For example, this validate code function will only take this code. Close door function will only take this slot ID. But when we call the functions which are present in the state, we would also pass the locker name as well. Why? Because we need to also validate whether the code entered is entered at the correct locker or not. So that's the reason why we would be passing the current locker name. Similarly, we'll also pass the locker name in closing the door function as well. All right. So we'll see that in a moment. So when the agent reaches the machine, he will first touch the screen. So this touch function of this locker machine would be called, okay, and this touch function would call the touch function of the appropriate state, okay. So initially the machine is in idle state, right? So in that case, we would go to the idle state. In the idle state, this function has this logic. So what will happen is we would have this in the console output, and the machine will go into the customer pickup state. Okay. So once the agent touches the screen, that machine would go into the customer pickup state. All right. And in the customer pickup state, he would click on the carrier entry option. So once he clicks on the carrier entry option, the machine would go into the carrier entry state. Okay. In the carrier entry state, he would select one of the two options. The first option is for the pickup of returned product, and the second option is delivering the package. So obviously the agent would be selecting the second option, which is the drop package. So if agent selects that option, the machine will go into the agent delivery state. All right. That is this state. Now in this state, the agent will be scanning the barcode which is present on the package. So once he scans the barcode, this function would be called. So in this function, I am checking whether the current locker name equals the delivery address of this package. Okay. So first of all, I am getting the package object with the help of this package repository. And then I'm checking whether the delivery address of this package is same as the name of the current locker. Why? Because we need to check whether the package is scanned at the correct locker or not, isn't it? So that's what I have done over here. Once we are sure that the package was scanned at the correct locker, we will get the locker object with the help of locker service, and then we'll get the slot. And then I'm just printing this stuff onto the console, indicating that this particular slot has been opened. So once the slot was opened, the delivery agent will place the package into that slot. Okay. Once he places that package into that slot, I'll update some details. Like I'll say that this package is now present in this slot, and I'll also update the status of this package. All right. And further, I'll also generate the OTP and send that OTP to the customer. So the customer will get the OTP over here, and customer will also be notified that they need to enter the OTP within the expiry time. Let's say the expiry time is 3 days. So the customer has to go to this locker. Okay, they have to go to this locker and enter this OTP within, let's say, 3 days. Okay. So once the customer has been notified, the machine will again go to the idle state. All right. So I hope now you understood the flow for the agent delivery. Once the agent delivers the package, the customer will go to the machine. Okay, he will touch the screen. So basically he will call the touch function of this idle state. So this idle state will move this machine to customer pickup state. Okay, so we'll go to this customer pickup state, and there he will enter the OTP. So once he enters the OTP, this function would be called. In this function, we would check whether the entered OTP is correct or not. If it is correct, in that case, one slot will get opened. Okay, we'll get the slot ID and we'll open that slot, right? And we'll also invalidate that OTP so that customer cannot enter that OTP again and again. And obviously the customer will take out the package from the slot, and then he will close the door. So once he closes the door, we would update the slot details. That is, we would release that slot so that it is again available for other users to select. And we would also remove the stored package from this slot. Okay, now it would become null. And again, the machine would go into the idle state. So this was the customer pickup flow. So I hope now you understood the customer pickup flow as well. Now let's check out the output of this entire code. Let me run the code. Okay. Okay, so there is one small update. So earlier we were having this line over here. Okay, so I have removed that from closed door function and I've inserted that line over here. Okay, so now if I run the code, you can see, first of all, the customer will search the locker based on the zip code and he will select one of the eligible locker. So let's say the customer selected the locker A. Okay, and then the customer will place the order. Once he places the order, one slot would be reserved. So let's say this is that slot and one agent would be assigned. Okay, so this is that agent. So this agent will further get the notification. So this is that notification. That is, the agent needs to deliver this package to this particular locker. Okay, and then that agent will collect that package from some hub and he will go to that Amazon locker. There he would touch the screen, then select the carrier entry, then select the drop package option, and then he would scan the package. Okay, so once he scans the package, this particular slot which was reserved will get opened. Okay, and after that he will place the package into that slot and close the door. Once he closes the door, the locker will go to the idle state and the customer will get notified. Okay, behind the scene one OTP will also be generated. So this is that OTP and the customer needs to enter that OTP within 3 days. All right, now once the customer gets notified, he will go to the Amazon locker, he will touch the screen, then he will enter the OTP. Once he enters the OTP, the slot will get opened. And after that, he will collect the package and close the door. So once he closes the door, the machine will go into the idle state and the package status will be updated to the picked up state. Okay. Now, I hope you understood all the 3 different flows, that is selection of the locker, package delivery by the agent and the customer pickup. If you did, then please like the video and share this with your friends. Thanks for watching.